So we're going to do number 30, the very last one on your review packet. It gives you a bunch of data, and it asks you a bunch of data, and it says that you need to do linear, quadratic, and exponential regression. So when you read it, it gives you this table of data. It says 1951 is 569. And it says 1967 is 608. And 1976 is 631. And 1978 is 636. So the first thing you need to do when you read this problem is realize that all those dates they give you are garbage. Because the very first sentence in part A says, if 1951 represents t equals 0. So that means 1951 is not anything to do with this problem. Instead, 0 is what we use there. Which means 1967 is not part of this problem. It's how long after 1951 is that? So you do 1967 minus 1951, and you get 16. Pen is not working. And then you do 1976 minus 1951, and you get 9 years more than 1967, but we're always going back to 1951. So you do 1976 minus 1951. And then 1978 minus 1951, which would be 27. You always subtract it from the first year, the t equals 0 year. Now we're going to pull out our calculator. We're going to enter this data. Go to stat. And we type in the data. So we're typing in x's are 0, 16, 25, and 27. Those x's, the t values that we just got. And then for the y values, we type in the y values. Those don't change. 569, 608, 631, and 636. It says to do regression with these. It says linear, quadratic, and exponential. So when you do linear, linear is the ax plus b. Quadratic is x squared, ax squared plus bx plus c. And then exponential, the last one it asks for, I'm going to choose the one that's a, b to the x. Every calculator has that one. So since we have our data typed in, we're going to go to calc, so F2. We're going to choose regression. And then X is the one for linear, so we're going to do that first. What we're paying attention to is the R squared value. So write down, with that linear, write down that R squared value, which is 0.9998716.8. Point 999, whoops. .87168. Now we're going to do the same thing with quadratic. So back to our calculator. Just hit exit. And now we're going to do the same thing with quadratic, which is x squared, so F3. And again, we're paying attention to our R squared value. 0.99999,427. And then last, we'll check exponential. So exit, exponential, EXP. If it gives you an option after you select that, choose the one that's AB to the X. Oh, this one doesn't even give me, it gives me the other one. Doesn't matter, it gives the same R squared value though. 0.99998674. So these are our R squared values. Now you look at the biggest one. The closest to 1 is the best grade. So we wrote out all the decimals so that we could compare them. The closest to 1, the highest score, is right there for Q, quadratic. So that means on our calculator, now we need to go back to quadratic so that we can write down what that equation was. Now, it is giving our answer with a E-3, which means times 10 to the negative third. That's scientific notation. So when you write it down, you probably don't want to write it that way. Instead, move the decimal 3 spots to the left, which would be 0.004. So it's Y equals 0.004. The directions do say to round to the thousandth, which is 3 decimal places, so that's it. X squared, and then plus BX, 2.374. Plus C, which is 568.996. So there's your formula. That's the equation of our regression, quadratic regression. So that answers all of part A. It says find which one's the best. Quadratic is the best. Write the equation. There it is. Now it says use your equation. So Casios have this feature where they can, TIs have a feature too, it's a little more complicated, but where you can just copy the equation and paste it onto the calculator. So copy it and then hit EXE to paste it. Now it's in Y1, so now we can use our Y1, and you can do it in table or graph. It doesn't matter. Table's a little bit easier. Table is, yeah, definitely easier. Don't have to worry about windows and things like that. You do need to select it though. You gotta have the little white box around the equal sign, so hit select. Then you can go to the table. Now, it is asking for the population in 1991. Now, 1991 would be year 40, because it starts in 1951. 1951 was year 0. So we care about year 40, so type in 40. That's our enrollment right there, 670.49. That would round down to just 670. So I'm just going to write 670. So in 1991, which is t equals 40, we get 670 people. Now, if on some of these, if you would have used a rounded equation, like you typed in this equation, rounded with the decimals, your answer might be slightly different. This one works out to be the same. Even if you did it, it would still be 670. It's only going to be off by a couple. It's not going to be off by a lot, if it is ever off. You should, if possible, copy the equation and paste it. All right. Next, we're going to take a look at a little bit similar. It is number 11. It talks about an athlete and their weight. It says, during the off season, an athlete weighed 240 pounds. And then later, 13 days later, he got his weight down to 228 pounds. So off season would be day 0. 13 days later would be day 13. So with this gives you 2 data points, which you can actually type in the exact same way we just did that last problem, which is why I said these can be related. But when you look at part A, it wants the equation that looks like n equals n naught e to the k d, which on your Casio has that option. When you go to exponential regression, it has that option. TIs, I don't think TIs have that option, which you have to do it a different way. So you can type these into stat. We're going to type in 0 to 40, the stat. Day 0 and day 13. Day 0 was 240 pounds, and day 13 was 228 pounds. And then if you go calc regression, you can go to exponential and choose the one that has an E in it, which is what this calculator is displaying. And you've got your entire equation right there. That actually answers both part A and part B if you do it this way. It answers part A and part B. Part A just says find K, which would be from the calculator's B. B is the calculator's K. Again, that's scientific notation, so you got to move the decimal 3 spots, so it's 0.003945. Yep, so rounded to a 10,000th, like it said, it'll be 0039. And it is negative. There's a -3 there, so make sure you put that on there. So that's K. The B from the calculator. Calculator gives you it as B. Then part B of the question wants you to write the equation, which would be n equals n naught, which your calculator says is 240 for A, A is 240. E to the KT. E to the K we just wrote down times T. So by typing it into your calculator, you don't even have to do anything except use the regression equation. Then the next part says, what would the mass be after 17 days? So you've got options. You can either retype this equation, which you'd probably type it rounded, or you can copy it and paste it. And then again, this time let's go to a, you could do table, but this time let's go to graph. You still have to select it, and you have to set up your window with a graph. So V window. We know what our numbers are going to look like. We know we're talking about how many days this guy's on a diet. Sometimes diets last a long time, so it could be 0 through like 180 days or something, maybe. Big amount of days just to make sure you've got it. Then your Y's, that's the guy's weight. Well, he's losing weight starting at 240. So 240 is the max. The minimum, guy can't weigh less than 0. That would not be healthy, though. And then you can draw it out. All right, so part C says, what's the guy's weight going to be at after 17 days? So we're typing in x equals 17. So that's a G solve. So we go to Y calc because we know the X value is 17 for 17 days. Now, depending on if you did a copy or if you did typing it in yourself, you might get different answers. If you copy it, like what I did on this calculator, you get 224 pounds. So part C, 17 days, it's 224 point something pounds. You can round to the nearest whole number. If you used your rounded equation, it's going to be 225. Close, but a little bit different. Part B, when will you reach the goal of 185? Similar calculator steps. This time we got to go G solve. We know the Y, so we're doing an X calc. And the Y is 185. That's his goal weight. And then looking at that, that's 65.967, so 66 days. I think if you used rounded on this one, 66 days. If you use the exact, if you used rounded, you would have got 67. I prefer you use exact. So on this problem, if your calculator does not give you the option for the exponential regression with an E, so like if you have a TI, it doesn't give you that option, you have to do this a little bit by hand. Just a little bit. So we're going into this formula that n equals n naught e to the kt. You plug in everything that you know. So we know that n naught is 240. So we plug in 240 right there. We know that n is 228. So we would say 228 equals 240. E to the k we don't know, but we do know that it took him 13 days for that weight change to happen. And you have to solve this by hand in order to get k. It's actually not that hard. You got to get e by itself, so we'll first divide, and then to change e, you have to do natural log. If you solve that out, 228 equals 240 e to the k times 13. First thing that you would do is divide by 240. Then we got to get rid of the e. You get rid of e by doing natural log. So now you do natural log of that fraction we just wrote down. And then e is gone, so we just have 13k left over. And then you're trying to get k. So then you divide by 13. Put that in your calculator, you get the exact same answer for k that the calculator gave. So type in natural log parentheses 228 over 240. Enter, divide by 13. You get the exact same thing that the calculator gave you if you have that option. Divided by 13, same thing, negative 396 e negative 3, so you got to move your decimal over. Same exact thing. All right, we're going to look at something like number 17. It's a money question. So with all of these money questions, we've always done where we write down the word parent. And then from the word problem, we pull out all that information. P is principal, the starting amount. On number 17, the principal is $10,000. A is the amount, the ending amount, which is a lot, 46,636.59. And then the interest rate, well, if you look at the question, it says, what is your interest rate? So that's what we're solving for. And then N and T, well, it says 21 years, that's T. And then N, for this particular problem, it says it's compounded quarterly, which means that we have an N equals 4, and we're not using E. E is only if it said compounded continuously. So we take all that stuff, we plug it into our formula. A equals T, 1 plus R over N, N, P. You fill in everything that we know. So 46,636.59 equals 10,000. 1 plus R, called it X, over N is 4. And then the exponent is N times T, 4 times 21, which is 84. The way that you solve this is similar to the way I just showed how to do your that last problem on the TI. You have to divide first. And we have parentheses to a power after that. We know the exponent, though. We're not trying to solve for the exponent. That's the difference. Since we know the exponent is 84, you have to do a root. Since it's an 84, you have to do the 84th root to get rid of that 84. Yeah. So you can type that in a couple of different ways. So I would start by doing the 46636.59 divided by 10,000. And then we want the 84th root of that, which you can do two ways. You could do to the power of 1 over 84, or there's a little, right above the little caret button, right below vars, it's x root. So you can type in 84 root. And then that number, so I'll just type shift answer. Or you could have done that 4.663659 to the power, type it in as a fraction, 1 over 84. It's the exact same thing. It doesn't matter. Either way. So we got 1.0185. That's 1.0185 equals 1 plus x over 4. We're just trying to solve for x. So our next step is subtract 1, and then our final step would be multiplied by 4. Our next step is to subtract 1, which just gets rid of that 1. So it's 0.0185. And your last step is multiplied by 4. So minus 1, and then multiply it by 4. So x equals 0.07399999. X equals 0.0739 blah 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 is 74. This is supposed to be a percentage though. So you rewrite that as a percentage. So that's 7.4%. Down to the nearest tenth of a percent.